Now, we have been constantly talking about words work and heat in this chapter so far, but we are going to talk about internal energy onwards now. So let's make a relation between how they are related and what exactly they are. We know about heat and work, that heat is a form of energy which when supplied to system, the system performs work, or when a system performs work, it can liberate an equal amount of energy. So heat and work are actually kind of correlated. But what about internal energy? So this is our new term which we are going to describe, internal energy. Consider this system of gas, okay, having these molecules, right, or atoms. Now, internal energy of a gas is the energy possessed, or I'm not just talking about in terms of gas, we are going to talk about in terms of system. So internal energy of a system is the energy possessed by virtue of its molecular motion and molecular configuration. Okay, so what we have term used, molecular what? Molecular motion and configuration. So this molecular motion means, as the name suggests, the movement of particles. So these particles would be in what type of motions? They would be in translational, kinetic, that means translational, vibratory and rotatory motion. So ultimately they all correspond to the word kinetic, right? So this basically, this term molecular motion means energy possessed by virtue of its kinetic types. Kinetic means the motion involving thing, right? So this is basically a kinetic energy, but we are writing it in the form of internal energy thing. So let's repeat, internal energy of a system is the energy possessed by system by virtue of its molecular motion and molecular configuration. Molecular motion corresponds to its kinetic energy, whereas molecular configuration corresponds to its potential energy, right? So it is the energy possessed by this potential, we are talking about this term now, it is the energy possessed by body by virtue of its interatomic forces, because all of these molecules are interacting with each other, so they are kind of having some forces, force of attraction, repulsion, something, some sort of forces in between them. So when you try to move a particle away from the system, the intermolecular force is to be distracted, right? So when we change intermolecular force, we have to put some work done, and that work gets stored in the form of energy. So that is why we call that internal energy on the basis of molecular configuration is called potential energy. So this is the total internal energy of a system. Now consider these two states. We have considered the system. Let's consider it for one ideal gas, okay, and one we are considering it for real gas. Now in ideal gas, we know that there is no intermolecular forces at all. That means we won't have to perform any kind of work, we don't have to supply any amount of energy to make these particles away from each other. That means internal energy due to its molecular configuration would be zero in case of ideal gas. So ideal gas will have energy only for molecular motion, that is, for ideal gas internal energy would comprise of only internal kinetic energy, and that will depends on the temperature, because you increase the temperature, the vibratory, translatory and rotational motion of all the particles are going to increase. So internal energy would be only internal kinetic energy. But in real situation, real gas, these intermolecular forces do exist and they are not negligible, all right? So we do have to perform some sort of work, we do have to apply some sort of energy to make these particles away from each other, and in that case there will be some potential energy stored in the system. So in real gases, the internal energy includes both kinetic as well as potential. Now this kinetic depends on temperature, whereas the potential energy depends on what? Volume. Basically you change the pressure, volume gets changed, so volume. So that is why they depends on both temperature and volume, whereas this thing depends only on temperature. This is all about internal energy of a system.